Hi everyone, today I am going to discuss section 3.4 which is the 5 number summary and box plots. 5 number summary includes quartiles like Q1, Q2, Q3 are quartiles. Q1 mean first quartile, Q2 is second quartile and Q3 is the third quartile. Okay, these quartiles we can discuss within any kind of unimodal shape, this rectangular shape, perfect bell shape, skewed shapes, whatever. First quartile, which means Q1, covers first 25% from the data set. Q2, the second quartile, it covers 50% from its data set, and the third one, third quartile Q3, it covers 75% from its data set. So, quartiles, first arrange the data in increasing order. This is very important. We need to arrange our data set into ascending order. Next, determine the median. Median is equals to Q2, second quartile. So, the next determine the median, then divide the data set into two halves, bottom half and the top half. The number of observation is odd, include the median in both halves. So, you should remember this one. If we have an odd number of observations, you have to add your mid value into both halves. First quartile, which means Q1, is the median of the bottom half. Here it is bottom half mean if you have a data set like this, divide into two pieces. So, this piece we call the bottom half in this case, bottom half. This is the upper half or top half, upper or top half. Okay. So, Q1 you can find median of the bottom half of the data set. Q2 is the median of the entire data set. Q2 is the median of the entire data set. And Q3 is the median of top half, this half. Okay, this is the procedure. Arrange the data set in ascending order. Find the median of the entire data set, which is Q2. Okay, median of the data set, which is Q2. Divide the ordered data set into two halves, bottom half and top half. If the number of observation is odd, then include the median into the both halves. Okay, find the median of the bottom half, which is Q1. Find the median of the top half, which is Q3. Then summarize the results. We will see how we do this. Here you can find this observations. First you need to convert this observation into ascending order. So, you have to check these values. I think if I am correct, 10, then it should be 15, then 16, 15, 16, 10 gone, then 20, then 18, then there are two 20s. So, 20 gone, then 25, 28 and 30. Okay. There are how many? N equal 3, 6, 9. There are 9 observations. So, this is an odd case. So, what you have to do? You have to add the middle guy. Simply you can find the Q2 by using its median, right. So, since this is 9, fourth one is the since this is 9, sorry, fifth one is the median. This is the Q2. You can find median using that equation, n plus 1 divided by 2. So, this is the median. Okay. So, you have to break this sequence into two pieces, lower half and upper half, including this value, because here you have odd number. So, you have to include this 20 into both pieces. Okay. So, lower half it is now 10, 15, 16, 18 and 20. So, upper half or top half, which is 20, 20, 25, 28 and 30. Now find the median of this, median of lower half. So, median of lower half is simply you can find this guy, which is 16, and median of upper half or top half, you can find here it is 25. So, now you have figured it out what is Q1 and what is Q3 as well. So, Q1 is 16, median is 20 and Q3 is 25. So, these are the quartiles. By using same technique you can find for even number case, but even number you do not need to add the median. Okay. Okay. I will just write that how we divide into two pieces, so that you can continue the example. I think this one the least one is 4, 5, 5. So, sequence is 4, 5, 5, then I can see 6 and 8, then 9, 10, 12, 13 and 18. So, in this case n equals to 3, 6, 9, 10, n is equals 10. So, that you can find easily, you can find Q2. What is Q2? Q2 is 8.5. Q2 is 8.5. So, these are the numbers you have to take the median average value of these two. So, 8.5. Now, you can get this is lower half and this is upper half. So, this is lower half and this is upper half. Okay. Then you can continue this work, how to find Q1, Q2 and Q3. Okay. Okay. There is something we call interquartile range, or simply we say IQR, by taking the difference between Q3 and Q1. If you find Q3 and Q1, take the difference, we call it interquartile range. Interquartile range does not consider any observation below Q1 and above Q3. So, if I have my Q1 here and Q3 here, this interquartile range, it does not consider values below Q1 and above Q3. This is better than range. This is better than range and standard deviation if data set has outliers. This is better than range and standard deviation if my data set has an outliers, because it does not matter about the outliers if you use this one. Okay. It is a good measurement rather than range and standard deviation. It is also a resistant measure, because it use median. So, median is a resistant measure, then IQR is also a resistant measure. Then we start this section by mentioning 5 number theory. So, 5 numbers, still we use 3 numbers, right, Q1, Q2, Q3. What are the other 2? Min and max. Including min and max, we call 5 number summary. Okay. So, outliers, there is a specific topic called outliers. It is like this. If okay, I will draw this one. Okay, I am sorry, this consider this as a line. I have observations from here to here like this. These are my observations, but unfortunately I have an observation somewhere here and somewhere here, very far from my data set. So, these guys we call outliers. They are far from our normal observations. Observations that fall well outside the overall pattern of the data, which called outliers. It may be the result of measurement or recording error. It can be error. This outliers caused by measurement or recording error, it clearly does not belong to the data set. That can be not inside the data set, so that we can simply remove this data, remove these outliers. We define lower and upper limits by using this quartile. So, lower limit we define Q1 minus 1.5 times IQR. When you find IQR, what is IQR? IQR is the interquartile range. IQR is Q3 minus Q1, Q3 minus Q1. Okay. So, using this lower limit is Q1 minus 1.5 IQR and upper limit is Q3 plus 1.5. So, this values like Q3 is here, Q2 is here, Q1 is here, and you will see that lower limit is somewhere here. This called lower limit, this one lower limit, and this called upper limit. Q3 plus something, so definitely greater than Q3. This is Q1 minus, definitely less than Q1. So, remember this one, lower limit and upper limit. So, in next section you will see what will happen for this lower limit and upper limit. Okay. Simply I can say that we are considering all values, all observations within this range, lower limit and upper limit. Okay. Okay, you will see more in a few slides later. Box plot, it is this box plot directly based on 5 number summary. Okay. Determine the quartiles, determine the outliers, draw horizontal axis and mention Q1, Q2, Q3 in there. So, box plot something very similar to this one. It is a box, this is the line. So, this is lower limit and upper limit, lower limit, upper limit. You will see a clear picture in next slide. This should be Q1, this should be Q2 and this should be Q3. This is the box plot. Connect the quartiles like this, like a box. Plot each outliers with asterisks. So, any observations in this range, any observations in this area we call outliers. Okay. You will see this one. This is how we step by step draw the box plot. First mention Q1, Q2, Q3. This is the axis values. So, this is the box plot, and finally mention your outliers if you have any. Okay. This is the lower limit, this is the upper limit. How do we calculate that? This is Q1 minus 1.5 IQR and this is Q3 plus 1.5 IQR. Okay. Any value greater than this or less than this we call outliers. Okay. Let us see what is this. This is runners and others. Okay. For the runners, box plot is this one. For others, our box plot is this one. You can see this here, Q1, Q2 and Q3. Gap between these values are larger than gap between these values. Okay. So, this is how it works. Box plot can be this gap is sometime greater than this gap or the other way, it does not matter, it depends on these Q1, Q2 values. Okay. Box plot for right is skewed, symmetric and left is skewed, it is like this. See, if it is a right is skewed, box plot can be like this. It is left hand side little bit low, little bit smaller than right hand side. If it is symmetric, it is perfect box. Again, left is skewed, the left side has the more area. Okay. For this case, if you need to draw the box plot, first you need to find these. You need to find what is Q1, Q2, Q3. Then you have to find lower limit and upper limit. You need to find this lower limit. You can find Q1 minus 1.5 IQR. Upper limit you can find Q3 plus 1.5 IQR. Okay. Then draw the box plot. You can do this example. Section 3.5 we discuss descriptive measures for population. Now we are going to discuss about population. Okay. Descriptive measures for population. Still we were talking about descriptive measures for sample. When we are talking about population, so population mean, it also has a mean, sample has a mean, population has a mean, we denote by mu. We denote by mu. So population mean, we denote population mean of the variable x, we denote by mu, summation of xi divided by population size. This n is the population size. Here it is capital N. So okay, after next slide I will explain you about sample and population, the difference between those two. Population is standard deviation. Also we have standard deviation for population. We denote by sigma. Sigma, it is this one, this notation. Sigma is equal to summation of xi minus mu square divided by capital N. Okay, or you can use this as well. Okay. So now what is the relationship between these population is standard deviation and population and sample is standard deviation, like that. So if you consider sample, it is not actually the relationship, it is the it is how we use this symbols. So don't confuse with that. If you are using sample, your mean is, sample mean is x bar, we call x bar. Sample standard deviation, standard deviation is simple s. But for the population, population mean is mu. Standard deviation, I will use std dev, which means standard deviation, it is sigma. So you can see notations are different. Okay. So don't confuse with these notations. So population and sample, for this ball diameter we can see population is bigger than sample. Okay. It's always happen. Standard deviation sigma, here for the population, standard deviation simple s for sample. Parameter and statistics. So parameter is a descriptive measure for a population, statistic a descriptive measure for sample. As I mentioned in chapter 1 video, descriptive measure for a population we call parameter and descriptive measure for sample we call statistic. Okay. Standardized variable, standardize, we sometime we need to standardize, take all the measurement into one standard measurement. It is important when we are doing some kind of calculations, especially data in data science calculations, or when we are dealing with huge data, we need to take all of them into one account, otherwise we cannot compare this value. For an example, I measure height in meters for particular number of students, and for the other students I'm taking their heights from centimeters. So if you consider meter and centimeter, they are measuring same thing, height, but meter and centimeter, they have very different values, right? Centimeter, 100 centimeter equals to 1 meter. So centimeter values are very large, larger than meter values. So at that time you have to take them into one account, otherwise you cannot compare them. At that point we can use this kind of standardizing. So C is the standardized value, X is the instant, or X is the X is the value we are considering, minus mu. Mu is the population mean divided by sigma. This is population mean, this is population mean, and sigma is the population standard deviation. I will write std dev, standard deviation. Okay. So this value also we call standardized variable, as well as C score. We use same name, standardized variable or C score. C score because this is simply said. So C score or standardized variable. Any value in different measurement we can take into same type of measurements by using this standardized this C score, this standardization procedure. Okay. So this is actually what I need to give you about this standardization or this population mean, standard deviation stuff. So I believe that you can have a better idea about these measurements through this video. So thank you very much watching this video, and I'll hope to continue in next chapters within next video series. So have a nice day and stay safe. Thank you very much.